So in this video, we're going to talk about how to use the polynomial remainder theorem. So remember we talked about how to evaluate functions that are in function notation. So for example, if we have f of x equals 3x plus 2, we can evaluate f of negative 5 by just taking that negative 5 and plugging it into this function everywhere we see x. Then all we need to do is work on simplifying this. And when we do that, we get f of negative 5 equals negative 13. So what if we wanted to evaluate a function like the polynomial functions we've been talking about? So for example, if we have f of x equals x to the fourth plus 3x cubed plus 2x minus 1, and we want to evaluate f of negative 2. Well, you can see when we plug it in, we have a lot of exponents and we have a lot of terms that are, some positive, some negative, so it's a lot to keep track of. So that's why we have the remainder theorem. So this theorem tells us that the remainder from synthetic division actually tells us the value of f of x. So here's that same example done during direct substitution. And then here is that same example done using synthetic division. So you can see what I've done here is in the upper left-hand corner, I use that negative 2, which is the value we're trying to evaluate. Then I wrote out all the coefficients of f of x. Remember that I added in that 0 because this f of x does not have an x squared term. And then we just do synthetic division like we normally would, and that value that I get here where the remainder should be actually tells me the value of f of negative 2. So you can see that we get the same answer using either method. And so using this process is also called doing synthetic substitution. So here's what we're going to do. We're going to start off making sure our polynomial is in standard form and add in any zeros for skipped terms. Then we'll set up our synthetic division and write down the coefficients of f of x. We'll then write the value of x in the upper left-hand corner and then do the steps of synthetic division. So bring down the first coefficient, multiply it by x, and then add it to the next coefficient, and then keep repeating until you have no coefficients left. The final value in the last row, where that remainder should be, tells you the value of f of x. So let's try this example. Given f of x equals 2x to the fourth plus x cubed minus x squared minus 2x minus 3, evaluate f of 2. So I'm just going to write down this f of x and make sure that I have no skipped terms. So I have 2x to the fourth. That x cubed I'm going to write as 1x cubed. And then minus x squared, that's going to be a minus 1x squared. And then minus 2x minus 3. So now let's set up our synthetic division. So this 2 is going to go in the upper left-hand corner because that's what I'm trying to evaluate. And then let's write out the coefficients of f of x. So we have 2, 1, negative 2, and minus 3. So now let's go ahead and do our synthetic division. So remember, I always bring down the first coefficient, so I bring down 2, and then I do 2 times 2, which is 4. 1 plus 4 is 5. I do 5 times 2, so that's 10. Negative 1 plus 10 is 9. 9 times 2 is 18. Negative 2 plus 18 is 16. 16 times 2 is 32. And 32 plus negative 3 is going to be 29. Okay, so that is what we get when we do f of 2. So in this case, we'd say that f of 2 is equal to 29. So now let's try synthetic division here. So we have f of x equals x cubed minus 4x squared plus 6x minus 3. So I'm just going to write this out and add in those coefficients of 1. So we have 1x cubed minus 4x squared plus 6x minus 3. So when you set up our synthetic substitution, we have 5 in the upper left-hand corner, and then we have the coefficients 1, negative 4, 6, negative 3. So let's start off by bringing down 1. 1 times 5 is 5. Negative 4 plus 5 is 1. So 1 times 5 is 5 again. And then 6 plus 5 is going to be 11. 11 times 5 is 55, and negative 3 plus 55 is 52. So that is our answer. So we would say that f of 5 equals 52. So now you can pause the video and try doing this example on your own. So here I just rewrote f of x, and then I added in that coefficient of 1 on my x term. So when I set up my synthetic substitution, I have my 3 in the upper left-hand corner, and then I wrote out all my coefficients of f of x. So I bring down 3. 3 times 3 is 9. Negative 6 plus 9 is 3. 3 times 3 is 9. 1 plus 9 is 10. And 10 times 3 is 30. And negative 11 plus 30 is 19. So we would say that f of 3 equals 19. So now let's try this example. So we're given f of x. It is in standard form, but notice we don't have zeros for our skipped terms. So I'm just going to rewrite this because we have a negative 4x to the fourth, but then we have no x to the third term. So I'm going to add in 0x to the third. I'm looking for an x squared term, but we don't have one of those either, so I add in 0x squared. And then we have a plus 2x term and minus 3. So I'm going to set up synthetic substitution and put this negative 2 in the upper left-hand corner. And then I'm going to write out all of these coefficients. So I have negative 4, 0, 0, 2, and minus 3. And let's go ahead and do our synthetic substitution now. So I bring down negative 4. Negative 2 times negative 4 is 8. 0 plus 8 is 8. Negative 2 times 8 is going to be negative 16. 0 plus negative 16 is negative 16. Negative 16 times negative 2 is going to be positive 32. 2 plus 32 is 34. 34 times negative 2 is negative 68. Negative 3 plus negative 68 is going to be negative 71. So we would say that f of negative 2 is negative 71. So now you can go ahead and pause the video and try doing this example on your own. So here, once again, you can see that we have our skipped terms that we need to add in. So we have 4x to the fifth, but then we need to add 0x to the fourth. We have a 2x cubed, and then we need a 1x squared, and then we add in a 0x term. And then we have minus 1. So we write out all these coefficients as our first row, and then we have negative 1 in the upper left-hand corner. 4 we bring down. 4 times negative 1 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times negative 1 is 4. 2 plus 4 is 6. 6 times negative 1 is negative 6. 1 plus negative 6 is negative 5. Negative 5 times negative 1 is 5. 0 plus 5 is 5. 5 times negative 1 is negative 5. Negative 1 plus negative 5 is negative 6. So we would say in this case that f of negative 1 is equal to negative 6. So now let's try this example. So in this one, you can see that we have a lot of large coefficients and we have some higher degree terms. So let's make sure that it's in standard form. So we have negative 8x cubed plus 90x squared plus 72x minus 3. So everything's in standard form. We have no skipped terms. We also are plugging in a fairly large value of x. So we have this 12. So let's go ahead and write out our coefficients. So we have negative 8, 90, 72, and minus 3. So we go ahead and bring down negative 8. We do 12 times negative 8, which is negative 96. 90 plus negative 96 is going to be negative 6. 12 times negative 6 is negative 72, so 72 plus negative 72 is 0. 12 times 0 is 0, so we have negative 3 plus 0, which is going to be negative 3. So we'd say that f of 12 equals negative 3. So I just want to emphasize the reason that I did this example. I want to show you that this actually is a quick shortcut that we are using. Because imagine if we were trying to do f of 12 by direct substitution, okay, we'd be trying to figure out negative 8 times 12 cubed plus 90 times 12 squared plus 72 times 12 minus 3. Okay, it is possible to figure this out and you can use your calculator to do this, but I just want you to see how you'd be typing in some very large numbers and having to keep track of everything. But whereas with synthetic substitution, you know, the numbers that you're working with are a little bit more manageable and it's easier to keep organized when you're doing this problem. So the remainder theorem allows us to use synthetic division to evaluate a function for a specific value of x. This can be very helpful, especially when working with polynomials involving higher powers and large coefficients.